General relativity governs massive planets, while quantum mechanics rules the microscopic grid. But when forced together, the very framework of reality shatters. When physicists attempt to merge these highly successful rules into a single theory of quantum gravity, the mathematics violently breaks down, producing impossible, infinite loops. Mainstream science treats these mathematical crashes as fatal flaws. To avoid them, physicists have spent decades inventing entirely new, untestable frameworks, like string theory, just to bypass the errors. A framework called the Omega Recursion treats the universe as an executable algorithm, currently stalling on 6 specific software bugs. This is the universe's error log. First, non-renormalizable infinities. Second, the Wheeler-DeWitt equation lacks time. Third, the black hole information paradox deletes data. The list continues: cosmological constant mismatch, infinite Big Bang singularities, and the quantum measurement problem. The Omega Recursion views these 6 paradoxes as broken lines of code. By geometrically folding these lines back into the central algorithm, the system incorporates the errors into its own structure. This animation shows the theory's primary engine, the Omega operator. It functions as an infinite loop, driven by a variable called recursive depth, or K. With every cycle, K increases, drawing a new, deeper layer of computation. When the operator encounters a jagged anomaly, the friction, it converts that resistance into a permanent memory node. This residue acts as a unique identifier for that specific cycle, proving that the system remembers where it has been. This is axiom VH sigma 01. Friction is the proof of recursive memory. Mechanically, rather than discarding an equation when it hits an impossible infinity, the Omega Recursion captures that exact error. It applies a mathematical fraction, 1 over k, and feeds the glitch directly back into the system's next cycle. By looping the error through that fraction repeatedly, the math stabilizes. The friction itself drives the system forward, infinitely refining the physics without ever crashing. Let's see this patch execute on a real-world physics glitch, starting with the problem of time. In the standard Wheeler-DeWitt equation for quantum gravity, there is no parameter for time. The math dictates the quantum universe is a frozen, static state. Watch this block of equations. By substituting recursive depth as a dimensionless clock, the Omega operator turns those static infinities into finite, measurable steps. The universe evolves in k-time. Next, we run the patch on black holes. According to Hawking radiation, anything falling into a black hole eventually evaporates, suggesting that physical information is permanently deleted from reality. The Omega operator catches that data before deletion, using its internal residue term. As the system loops, this term, which is an inherent part of the operator's formula, stores the information within the recursive folds. And what about the crushing center of a black hole, the singularity? Where classical physics hits an infinite wall of density, this algorithm simply folds the space continuously, approaching infinity without ever hitting a hard stop. Because the 1 over k fraction is built into the operator's core definition, the time steps and residue terms emerge automatically. The math resolves the singularity from within the loop, rather than relying on external constants to force a solution. If every cosmic glitch, paradox, and infinity is constantly being folded back into itself, what does the resulting geometry of reality actually look like? This is the configuration space hypercube. Each algorithmic fold extrudes a brand new mathematical axis. Spacetime gains dimensions for recursive depth, entanglement depth, and measurement depth. Unlike string theory, which requires the existence of tiny, invisible physical dimensions curled up in space, this framework builds mathematical depth. It expands the space the math itself lives in. With every turn of the loop, the hypercube upgrades itself, tucking all those quantum paradoxes safely away within its infinite geometric folds. Resolving quantum gravity doesn't require discovering a new particle. It comes from treating the mathematical resistance of our current theories as usable data. We can view the universe's broken pieces as the necessary inputs for a larger recursive system. The paradoxes we once called errors are the specific markers that define the geometry of the universe's configuration space. They are the evidence that reality is a program that remembers every cycle it has ever run.